Welcome to the course Analysis of Structures. In previous lectures, we discussed on arch and parts of arch and types of arches. Today, let us discuss on problems of arches. Initially, we start with three-hinged arch. A three-hinged arch is a geometrically unchangeable, statically determinate structure which consists of two curvilinear members. These are the curvilinear members. It consists of two curvilinear members connected together by means of a hinge. This is the hinge with two hinged supports. These are the hinged supports 1 and 2. Two hinged supports resting on the abutment. This is the description of the three-hinged arch. In case of three-hinged arch, we have three hinges 1, 2 and 3. One hinge at the center or at the crown, thus making it statically determinate structure. This hinge is making the arch a statically determinate structure. Reason is due to the hinge we will be having the bending moment at this hinge as 0. So we will get one extra equation to find out the unknown variables. If the shape of this arch is parabolic, then it is called parabolic arch. The shape of the arch is parabolic, then it is called parabolic arch. Okay, now let us solve problems. Suppose a two-hinged arch. The two-hinged arch can be made statically determinate by introducing a third hinge at the crown of the arch. This is the third hinge. Now let us consider the three-hinged arch shown in figure. This is the three-hinged arch, 1, 2 and 3 hinges. This type of arch is statically determinate. Reason because an extra equation is available by taking bending moments of all right and right hand side forces about to C as 0. Why this three-hinged arch became statically determinate structure? Reason is bending moments of all left or right hand side forces about C as 0. Okay, now you observe this figure. Same figure I repeated in this slide. You observe this span of this three-hinged arch is about 5 meter plus 5 meter, 10 meters, and raise of this arch is 3 meters from here to here, the distance, and a point load of 100 kilonewtons is acting at a distance of 2 meters from the left support at a height of 2.5 meters. here. Now, with this information, let us find out the reactions acting at these hinges. The reactions are VA. VA means vertical reaction. This is vertical reaction at A, support A. VB, vertical reaction VB at support B. And HA and HB are the horizontal reactions. HA is the horizontal reaction at support A and HB is the horizontal reaction at support B. Now we have to find out the values of VA, HA, VB and HB with by this given information. Considering this given information, we have to find out VA, VB, HA and HB. Solution. Let us first obtain vertical reactions. Vertical reactions means VA and VB. Taking moments about A. A is here. Taking moments about A of all the forces, we get this equation. You can see A is located at a distance of 10 meters, 5 meter plus 5 meter from the support to B. So we can write moment about A is VB into 10. VB into 10. This is anti-clockwise direction will be taken as positive. Then if the clockwise moment is taken as negative, 100 kilonewtons to distance is 2 meters. 100 into 2. Because it is clockwise direction, this moment is taken as negative. Here, this moment is anti-clockwise, and here, this is clockwise direction. Anti-clockwise direction. So, from this equation, we can calculate VB. You move it to right hand side, 100 into 2 divided by 10, VB is equal to 20 kilonewtons. Cancellation by solving, we get VB is 20. See, now we have to calculate VA. Total vertical force. If you observe in the figure, total vertical force on this arch is 100 kilonewtons. So if we apply equilibrium equation along the vertical direction, we can write VA plus VB is equal to 100. Now VA is equal to 100 kilonewton minus VB. VB, we already know VB is 20. So 100 kilonewton minus 20 kilonewton gives 80 kilonewtons. Okay, now we'll move to next slide. Now we previously here we calculated YA and VB we calculated. Now let us calculate the horizontal HA and HB horizontal reactions. Now let us take moments about C of all the forces acting on the right hand side of hinge C. Right hand side means this portion. This is the right hand side of C. So if we take moments about right hand side from right hand side, VB into 5. This is the C distance. 5 meter is the distance between the support B and crown C. So VB into 5 minus HB into 3 meters. 3 is the distance, perpendicular distance to this force. Moment we have to calculate as force into perpendicular distance. HB is the force and perpendicular distance is 3 meters. So HB into 3 is equal to 0. Reason is moment at C is always 0. Reason because it is a hinge. Hinge is located at a point C. Remember, whenever hinge comes in a structure, their bending moment will be 0. So, using that principle, we made it here 0. Now, we calculate HB is equal to VB into 5 by 3. VB already we calculated, which is equal to 20. You substitute that 20 in the place of VB, becomes 20 into 5 by 3. That means 100 by 3. Then it becomes HB is equal to 33.3 kilonewtons acting towards the right side, right direction. This is the direction of this force. Applying next to find out HA, now HA is left. Applying equilibrium equation, sigma Fx is equal to 0 implies HA is in this direction because for equilibrium oppositely these forces should be opposite in direction. So we can write as HA minus HB is equal to 0. HB already we calculated, substitute, then it becomes HA minus HB is equal to 0. It means HA is equal to HB and HA is equal to 33.3 kilonewtons acting towards left. Here directions of this force are, these symbols are directions of that reaction. It is in this direction and HB is in this direction. Okay, now let us find out the bending moment at D. Bending moment at D is as follows. For calculation of bending moment at D, that means here we have to find out bending moment. The bending moment at D is as follows. MD is equal to VA force into perpendicular distance 2 meter, VA into 2 minus HA into perpendicular distance, that is given as 2.5 meter, HA into 2.5. Substitute the previous found out values. VA is substituted by 80 and HA is replaced by 33.3, and the bending moment comes out to be, on solving, 76.75 kilonewton meter. This is the bending moment obtained for the 3-hinged arch. Now let us compare this value, obtained bending moment. Suppose this hinge is made as simply supported beam of the same span and loading. That means I will draw the diagram here. Same span and 100 kilonewtons A, B. Now find out the bending moment at D in the case of simply supported beam. In this case, what happens? Comparing this with a simply supported beam, this means bending moment MD. Comparing this MD with a simply supported beam of same span and loading, in the case of simply supported beam, MD will be VA into 2 is equal to 80 into 2, equal to 160 kilonewton meter. In the case of arch, bending moment is 76.75, but in the case of simply supported beam, it is 160 kilonewton meter. That means in the case of arch, the value of bending moment is reduced. Therefore, as it was brought out in the section, the arch action reduced the moment. Because of this arch shape, the bending moment is reduced at D by a value equal to 52%. 160 is simply supported bending moment value and 76.75 is the bending moment due to in the arch, divided by 160 into 100 gives 52% of bending moment is reduced in the case of arch. Okay, now let us see another problem. 3-hinged symmetrical parabolic arch. As I told you, if the shape of the arch is parabola, then it is called parabolic arch. Symmetrical means with respect to this central axis, should be symmetry. You can observe this figure. Along the axis C, the shape is similar on either side of this axis. So it is called symmetrical. The below figure, this is the figure, shows a 3-hinged symmetrical parabolic arch of span 100 meters. Here you can see the 100 meters and central raise 25 meter. Here it is marked 25 meters. It is required to find the support reactions due to the loading shown. Loading is this uniformly distributed load. This is a uniformly distributed load of 2 kilonewton per meter on the left hand side, left half of the span, half of the span. The left half of the span carries a uniformly distributed load of 2 kilonewton per meter, while two concentrated loads, these are the concentrated loads of 50 kilonewton and 100 kilonewton, act at 30 meters from right hand support. Right hand support is B. From here it is 30 meters and 100 is 10 meters. That is given here. Now we have to find out the support reactions. This VA, VB, HA, HV we have to calculate. The problem is almost similar to the previous problem, but only thing is more loading is given in this problem. More loading is there. UDL is provided and here concentrated loads, two more concentrated loads are provided. Now let us move to the solution. For sake of solving solution easily, to solve the problem easily, I am repeating this same figure in the next slides also, so that it is easy to observe the values, given values, and substitute while solving the problem. Here the same figure is reproduced here. Now we do the solution. We know the equation of the symmetrical parabolic arch. Equation of symmetrical parabolic arch with A. A is here. With A as origin can be written as follows. Suppose if we assume this as origin, this is y direction and this is x direction and origin is here, then this equation of the symmetric parabolic arch can be written as y is equal to 4h by L square x into L minus x, where h is the raise, this is h, L is the span, L is this and h is this, x is the distance from the origin. If we move this direction, then we will get the y coordinate. Then we can construct the parabolic arch with the help of this equation. I have given explanation where x and y are coordinates of any point P. Any point. It may be here or here or here, anywhere. H is the central raise of the arch. Central raise is this, which is equal to 25 meters. And L is the span of the arch, span, 100 meters span. Okay, in the present example, continuation of the problem. In the present example, h is equal to 25 meters, L is equal to 100 meters. Hence, the equation of the arch will become y is equal to, substitute in this equation, 4 into 25 divided by 100 square into x into 100 minus x. That is here. 4 into 25 divided by 100 square into x into 100 minus x. So what happens here? 4 into 25 is 100. Here numerator 100 and denominator 100 cancels. 100 gets cancelled. So this equation becomes x into 100 minus x by 100. Y is equal to x into 100 minus x by 100. The height of the load point D will be, D is here. In the figure you can see the height of this point D can be calculated by this equation. Substituting in this equation, yd is this, we have to find out. In the given problem, this distance is not given, we have to find out this. After finding out, mark, it is marked here. How to find out? Substitute in this. Yd is equal to, x is the distance, how much? 50 meters plus 20 meter. The D is located at a distance of 70 meter. X is equal to 70. 100 minus x. Substitute in this. 70 into 100 minus 70 divided by 100. Then we will get 21 meters. So we are able to find out this height of the point D at a distance of 70 meter. Similarly, height of point E at a distance of 90 meter. 50 plus 20 plus 20. Substitute in this equation. 90 to 100 minus 90 divided by 100 comes out to be, it is equal to 9 meter. This 9 meter is nothing but this distance. Okay, right? Now continue. Yes. Now taking moments about B where it is at a right hand support. Here B. Now taking moments about B and applying the condition sigma mb is equal to 0. That means summation of bending moments at B is equal to 0. Reason is, at support B, hinge is located. Hinge. Wherever, I told you, in the structures, wherever hinge is, we find their bending moment will comes to be 0. So, with that principle, we can write sigma mb is equal to 0. Now, find out what is sigma mb. VA into this distance, VA into 100 minus, this is UDL, per meter load is 2 kilonewton. But so total load for 50 meters will be 2 into 50 meters. That means 100. This is into distance. This is load acts at the center of this. That means it is at 25 meters from the support to A. Then it will be 75 meters from the support to B. It will act at this. So from this point to support to B, it will be 75 meters. That is why this distance is written. 2 into 50 into 75 minus 50 into 30 meters. This is the distance 30. 50 into 30. Similarly, minus 100 into 10 meters is equal to 0. This is the sigma mb. It is equal to 0. So we made it equal to 0. Then on solving this equation, we get VA is equal to 100 kilonewtons. That is written here. This VA is equal to 100 kilonewtons is written here. You can observe. Now, in order to find out VB, applying the condition of vertical equilibrium, that means whatever the forces vertically upwards and vertically downwards both should be equal. Otherwise, VA means VA plus VB is equal to this total downward force, that is 2 into 50, that is why it is written here 2 into 50 plus 50 plus 100 is equal to 250. Already we know what is value of VA and substitute the value of VA. Therefore, we will get VB is equal to 250 minus 100 is equal to 150 kilonewtons. This 100 is VA. VA is equal to 100. Substitute here. We get VB is equal to 150 kilonewtons. So here it is written as 150 kilonewtons. Similarly, now what is left? We found already VA and VB. Now we have to calculate horizontal reactions HA and HB. To calculate horizontal reactions, we'll take this step. Bending moment at a central hinge C is 0. Therefore, taking moments of all left-hand forces about C, we can take, here I have taken left-hand forces. For example, for exercise purpose, you can take right-hand forces. Though if you take left-hand forces or right-hand forces, answer should be, will come same. Here we will see for left-hand forces, VA into 50 meters because C is at a distance of 50. VA into 50 minus HA into height 2.5. This is 2.5. Okay. Now, due to this load, moment due to this load, what is that? 2 into 50 and it is located at 25 meters here. And this is 25. So 2 into 50 into 25 is equal to 0. On substituting VA, we can calculate HA. VA is 100. 100 into 50 minus HA into 25 minus 2 into 50 into 25 gives is equal to 0. On solving this equation, we get HA comes to be 100 kilonewtons. Acting towards right direction, in this direction as shown in figure. Also considering horizontal equilibrium, previously to calculate VA and VB, we considered vertical equilibrium, but for horizontal reactions, we consider horizontal equilibrium of arch, then HB will also be 100 kilonewtons, but acting towards left at B as shown in figure. Okay, that is the problem. Now let us see another example. Here another example, only change is unsymmetrical parabolic arch. In the previous case, here it is symmetrical arch. Now we'll solve one problem in the case of unsymmetrical arch. Unsymmetrical parabolic arch. The below figure shows an unsymmetrical parabolic arch of span 90 meters. You see in the figure, span is 90 meter. The right hand springing B, right hand springing means the end of the arch. This B is 90 meter, 9 meter, 9 meter above the left hand springing A. Left hand is springing is here, right hand springing is here. This right hand springing is 9 meters above the left hand springing. That is why 9 meter above we located this. At a span of 90 meters. The crown C is at 50 meter. This is the crown from A. Okay. And 25 meter above it. That means here 25 meter. Right? It is required to find the reactions under the given loads at D. D is located here. These are the given loads 100 kilonewtons and 50 kilonewtons. Now we have to find out the reactions. The reactions means VA, VB, HA, HB. We have to find out in this problem. The problem here, the arch is unsymmetrical parabolic arch. Now let us solve this. I am repeating this figure in each slide so that while solving the problem it is easy to observe the values or measurements given in this arch. Otherwise, we have to come to this slide, observe and go to another slide. To avoid that difficulty, I am repeating this slide, this figure in each slide here. Now similarly as previous example, taking A as origin, let the equation of the parabola be, this is the parabola equation, y is equal to ax square, general equation y is equal to ax square plus bx plus c. This is the general equation of parabola, parabolic shape. Suppose it is symmetrical arch. If it is a symmetrical arch, the equation will be y is equal to 4h by L square into x into L minus x. If the parabola is symmetry, in this case, parabola is unsymmetrical. So the equation, general equation of parabola is ax square plus bx plus c. Since at A, we know coordinate of y is 0. At A, y is equal to 0 when x is equal to 0. At A, x is 0, y is 0. At C, here, what is the coordinate, how to get, substitute in this, we will get. X already we know the distance is, C is located at a distance of 50 meters from support A. That means it is x is 50. Substitute value of x here as 50. Bx is 50. Then we will get y is equal to 25 when x is equal to 50. And at B is this. When x is equal to 90, then y comes out to be 9 meter. So now we have following three equations to determine A, B, C. Now we have to find out A, B and C by using these values. How? Here. Now we have following three equations to determine A, B, C. That is, y is equal to 0, A is 0 square plus B into 0 plus C. That means this term becomes 0 and this also becomes 0. Then C comes to be 0. C is equal to 0. Now substitute y is equal to 25 when x is equal to 50. Substitute in this, then we by solving this equation 3 and equation 4, we get a is equal to minus 1 by 100 and b is equal to 1 by solving equation 3 and equation 4. These values how you got? This is 25 meter given in the problem here, 25 meter, and distance is x is 50. Y value, x value. Substitute in this equation, then we'll get the like that equation 3. So by using these two equations, we can find out a is equal to minus 100 and b is equal to 1. A is equal to minus 1 by 100. C is already 0. From the equation 2, C is equal to 0. By substituting above values in equation 1, the equation of parabola becomes, now you substitute here, this is equation 1. Substitute in this equation 1 the values of a, b, c. Now the equation becomes this one. This is minus 1 by 100 is ax square plus bx. B is 1 plus c is 0. And this equation becomes like this. X into 100 minus x by 100. Hence, the raise of the point D is given by, now we know distance of D is 30 meter. To find out the raise of this point D, substitute in this equation x is equal to 30, 100 minus 30 by 100 comes out to be 21 meter. This is the raise of point D. Okay. Now taking moments of all forces about B and applying sigma mb is equal to 0, we get, this is taking moments of all forces about support B and applying sigma mb is equal to 0, we get this VA into distance 90 minus HA into 9 meters minus 100. This is 100 minus why you got VA is this direction we have taken here in this problem. VA into 90 is this. That means clockwise direction. Here we have taken positive. This HA into 9. If we observe, this is in anti-clockwise direction. So we kept a minus here. Similarly, 100 into this distance 40 plus 20, 60. This is also anti-clockwise direction. So negative. Here positive. VA, VA into this distance. VA into this is clockwise direction, so it is taken as positive. And here in this case, then if clockwise becomes positive, anti-clockwise becomes negative direction. That is why we have taken minus values here. And suppose, and this one you see, 50 is becoming again clockwise. 50 into this distance. 50 is how much? 21 minus 9 gives this height. That is why here 50 into 21 is this height and 9 is this height. 21 minus 9, what distance will get? We'll get 21 minus 9. Okay, and substituting, we can, since the bending moment at C is 0, this is equation obtained for sigma MB is equal to 0. And now if we write similarly for MC on the left hand forces, we have this equation VA into 50 minus HA into 25 minus 100 into 20 minus 25, 50 into 25 minus 21 gives this. That is why here it is written 25 minus 21 is equal to 0. Now on solving equations 6 and 7, we can find out VA as 64 kilonewtons and HA as 40 kilonewtons. On solving this equation, these two equations, we can find out the values of VA and HA. Okay, now here it is marked as equation 8. Only difference between previous slide and next slide is here I marked as VA as 64 kilo and HA as 40 kilonewtons as equation 8. Now with this help of VA and HA, we can find out the values of VB and HB. Let us see how to do that. Considering vertical equilibrium, VA plus VB is equal to 100. You can observe the figure. Here vertical forces, sum of the vertical forces is 100 kilonewtons. To resist this 100 kilonewtons, the sum of the reactions at VA and VB should be 100. That is why VA plus VB is equal to 100. On substituting VA from equation 8 gives VB is equal to 36 kilonewton. Now we got 36. And considering horizontal equilibrium, HA plus HB is equal to 50. Horizontal is 50. So on substituting like that, HA plus HB is equal to 50. On substituting in that the value of HA, we can find out HB, which is equal to 90 kilonewtons. Here we added HA plus 50 is equal to HB. Reason is HA is in this direction, 50 kilonewton is also in the same direction. That is why we added here. Both directions are same, so we have taken positive values is equal to HB. This is opposite direction. On substituting HA value, we get HB as 90 kilonewtons. That is written here. Okay, thank you for today. Next class, we'll continue with some more problems on 3 hinged arches. Then we'll go for 2 hinged arches also. 2 hinged arches are indeterminate, statically indeterminate structures. Reason is there the hinged crown is missing. Only the hinges at supports are available, and it is somewhat little bit difficult when compared to 3 hinged arches. We'll see in the next class. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.